Today on SCIENSTORICAL, maths. Matt Damon may or may not be included. I've spent a lot of my scientific life buried up to my neck in statistics, specifically hypothesis testing. In science, we do a lot of experimental work. We have a hypothesis, we design an experiment, we test for that experiment, and then we have to trawl through the data. But the thing is, how do you tell that the data that you've got is actually telling you something that's worth something? The answer lies in statistics. Science is all about finding a significant result, and how do you know that your results are significant? You run statistics on them. In particular, you do a thing called hypothesis testing. We have one hypothesis, you have an alternative hypothesis, and if the results tell you that those two are significantly different, you have a significant result. Your experiment showed something changed, and it changed in a significant way. But how do you know that you're using the right statistical test? There are literally millions of them out there. You've got the student's t-test, you've got analysis of variance, you've got one-way analysis of variance, two-way analysis of variance, repeated measures, ANOVA, you've got so many different options. How do you tell which one's which? How do you tell which one is giving you the best result? In the early 20th century, there was a statistician named Jerzy Neyman. He worked for the University of California in Berkeley, and he is the one responsible for hypothesis testing. He is essentially the author of my nightmares. But alongside that, he also developed a specific test to determine whether or not the hypothesis testing method that you're using is the right one. But there was a problem. It didn't have any mathematical proof. Now, in maths, you need to be able to provide mathematical proofs for your method. And all that is really an argument that proves that your method is always true or always false. Neyman, along with being a researcher, was also a teacher. It's pretty common with most professors. One day, Neyman was teaching a class of PhD students. He turned around and wrote up a series of statistics problems up on the board. There were two of them, and they were really complicated. There was this one PhD student in his class who walked in late. He walked in, sat at the back, and diligently copied down the two statistics problems that his professor had put up on the board. The class finished, he went home, and he got started on his homework. It took him a lot longer than he thought it would, and he ended up handing in his homework late. He walked into Neyman's office and said, do you still want to see my homework? And Neyman was like, yeah, sure, just chuck it on the desk. Which is a little bit kind of easier said than done, because there wasn't really an awful lot of space left on the professor's desk for this student to chuck his work onto. I have a feeling he kind of looked at it and went, that's going to get lost forever. Fast forward to about 6 weeks later, and this PhD student is asleep in his house when there's a knock on the door. It was some unearthly hour of the morning, and he stumbled downstairs to open up the door, and there is Professor Neyman. He has the crazy eyes, and he rushes inside, thrusts this piece of paper at this PhD student and says, I've written the introduction to your paper, can you read it and sign off on it so I can send it off to be published? And presumably the PhD student was like, huh? Because, you know, it was stupid o'clock in the morning, unless he was one of those freakish people who can wake up and just be like, hello world, I'm here for you, yay! I am not one of those people. Later on in an interview, George Danzig, the PhD student in question, said that this was the first inkling I had that there was anything special about them. He was talking about the maths problems. You see, before Danzig had managed to get to class, Neyman had put up on the board two examples of unsolvable statistics problems. George Danzig had unwittingly provided the mathematical proofs required for these two really famous problems that refine likelihood ratios and null hypothesis testing and are still in use today. Later on, when Danzig approached Neyman to ask about what his thesis topic should be, Neyman apparently just turned to him and said, you know what? You know those two mathematical proofs you handed in as homework a few years ago? Yeah, just shove them in a binder and whack your name on it and we'll call it done. I hate him. If only it were that easy all the time! Danzig later went on to become the father of what's called linear programming, a method that takes a ridiculous, mind-blowing number of variables and models future scenarios. It's used in economics, air flight traffic control, nutrition, investment banking, and many, many other disciplines. Danzig would not have been able to solve those problems if he'd realized they were unsolvable in the first place. There were no psychological barriers to him sitting down and working through those problems. He thought that because they were homework, they clearly had a solution, and so he found one. Maybe the moral of this story is to pretend everything's homework and nothing's unsolvable, and maybe you'll be able to trick your brain into having a similar happy accident. Good luck! Oh, I promised you guys Matt Damon, didn't I? I'm very sorry. Did you know that this story was actually the inspiration for the movie Good Will Hunting? It's a pretty good movie. I don't actually remember an awful lot of it. I remember there's lots of crying. And Robin Williams. Lots of Robin Williams and lots of crying. It was a pretty good movie. I enjoyed it. Matt Damon didn't actually get rescued in that movie. Oh, he kind of did, I suppose. Maybe psychologically rescued, but they didn't have to spend an awful lot of money, you know, getting him back from Mars or rescuing him in the Second World War. It's a pretty good film. All about maths. Maths is really important. Not at all boring. It's really fun. I am a little bit of a glutton for punishment, though. I did enjoy doing a lot of like multivariate statistical analysis. It's called chemometrics. It's really fun.